It is my pleasure to introduce today's presenter, Dr. Lorien Pratt. Dr. Pratt has 3 decades of experience delivering applied AI, ML, and NLP solutions. Her clients have included the Human Genome Project, SAP, the Colorado Bureau of Investigation, the U.S. Department of Energy, the Administrative Office of U.S. Courts, and dozens more. She is the celebrated author of Link, How Decision Intelligence Connects Data, Actions, and Outcomes for a Better World. Dr. Pratt, it's all yours. Let's begin.
Thank you, everyone, and I appreciate you joining us for this very important webinar today. Data is everywhere. It is arguably the seventh sense of humanity. It is the way we learn about outer space, about our own planet, and most importantly for today, how we learn about people. We have massive sources of data, whether it's epidemiological data about COVID or behavioral data or more. The problem is that there is a data mountain surrounded by an analysis and effective action desert. Only a tiny fraction of data today is even analyzed to come up with answers to questions. And an even smaller fraction is then converted from questions to actions that we can take that are effective. And coronavirus is a particularly important issue. So today we'll talk about how we can use AI to overcome that analysis desert and how we can use it to help to find patterns in data to move it a little bit closer to being actionable. However, AI is not enough. There still is an evidence-based decisions desert. AI gives us answers, classifications, predictions, but it doesn't necessarily tell us if we make this decision, what will be the outcome of this decision. Decision makers who wish to make evidence-based decisions, whether they are government officials or corporate experts, or even you as an individual deciding whether to return to the workplace physically, to get a different job, to stay working from home, you are separated from this data mountain. You're separated from the AI. I've drawn a brick wall here to sort of represent that. Most people don't have access to these massive amounts of data. And even if they did, the data would be overwhelming. You know, nobody wants to be emailed a database and say, okay, make a good COVID decision. That doesn't make sense. Up until now, AI has been used for certain kinds of automated use cases. It's been used for problems like which ad should I show, which stock should I trade, which direction should I turn the car. So AI has been used in these, what we might call darkroom, fully automated situations in which we don't have a human in the loop, in which we need to make tens of thousands of decisions typically every second. This has been where AI has been the most successful. The situation with COVID-19 and the coronavirus is quite different, but AI has a really critical role to play. Whether you're a corporate office manager, a government, federal, state, or city decision maker, if you're in charge of a unique setting like a nursing home or a meatpacking plant, or you're a consultant to one of these groups trying to help them make the best decisions to stay alive, to help society in the way they always have as a business, but at the same time to protect their employees, which is, you know, quite a difficult decision that most organizations have not had to face in this way ever in the past. You are also an important decision maker in this loop, and individuals have been, as I said earlier, typically separated from the data and the AI that helps them make the decisions. Organizations in these roles have lots of decisions that they can make. Social distancing policies, masks. It turns out UV lights might have an impact on coronavirus. Staggered hours, tape, plexiglass, wiping down multi-use items in a nursing home. Lots of different decisions in many different environments. Importantly, these decisions apply today. This is not just about a hypothetical return to work future. Many workplaces are maintaining skeleton crews, whether they're a nuclear power plant or an office building that's kept some critical key employees in place. But certainly there are also essential workers that are also being asked to continue to work within proximity to each other. How do we use data, this massively valuable resource, and then also AI to turn that resource into value? A key concept here is intelligence augmentation, or IA. started by Doug Engelbart, who invented the mouse and the hyperlink. And you can look at his video called The Mother of All Demos, which is quite fascinating, from back in the 1960s. IA has been kind of ignored. This is the idea that AI and other advanced technologies can help to overcome cognitive limitations that humans have as they make difficult decisions. So far, data has helped us a bit in this space. We're able to understand things that are bigger, smaller, or further away than we've ever been able to understand before. So in that sense, AI is like the seventh sense of humanity. It's giving us this new capability. But again, if somebody just threw a database in your email, that's not enough. So machine learning helps us here. It helps us find patterns in that data. So if I have 10,000 rows of a data set of somebody's clinical information and whether they have COVID or not, it might discover some subtle patterns that based on your demographic and your clinical information, it's able to determine whether you have COVID as one of hundreds and hundreds of examples where we use machine learning to find patterns of information. But these are only two cognitive limitations. As we stand up to face one of the most challenging situations of our time, data and AI are not quite enough. We also need to understand how our actions play out over space and time through multiple links. As I make a social isolation decision, how is that going to impact my health? How is it going to impact the health of people I might run into? That's hard for people to understand. Invisible things like infection and coronaviruses, particles floating through the air, hard for people to understand. Exponential curves, the idea that there are two kinds of small things, one that's the core of a bomb that's going to explode, and another small thing that's going to stay small. How can we understand that? Combining multiple charts and graphs, there's kind of this fiction that we can look at all these model results and assemble them in our heads to make good decisions. That's not true, but computers can help us keep track of decision structures, emergent behavior, nonlinear and feedback effects. All of these elements are characteristics of COVID, but also characteristic of a class of problems we'll talk about going forward that goes beyond COVID. So today we have quite an ambitious set of goals. So by just because of our limitations, I'll just be able to touch on this, working breadth first through this space. There's a lot of additional information here with more details, and a good resource to start with, again, is my book that you can find on LinkedIn. It's called Link. So we'll talk about what are AI. If you're not familiar with AI, what is IA, intelligence augmentation, and what's this new field called decision intelligence that's just recently been recognized by organizations like Gartner and Forbes and more. How can we use models plus visualization to help with those key decisions that influence both risk as well as the viability of our business? How can these visualizations make these complex and invisible ideas more understandable, not just if you're a professional in this space, but also in a democratized world, it's important that everyone has access to actionable information. Turns out we need multiple AI models in the chain from decisions to outcomes. We'll talk about that. Agent-based simulation, how to find patterns in data, and how to incorporate new data. Throughout this presentation today, I will give you a number of practical steps that you can take immediately for both business leaders and technologists. You know, let's be honest, some of this stuff can feel pretty overwhelming to a non-technologist. The language of AI and DI can feel sort of jargony. So I think it's really important, not just in this presentation, but in our careers going forward, that we work to break through that information logjam. It is our ethical responsibility, I believe, to make this technology, this understanding available to as many people as possible. So with the help of Ted Danson and the folks on the television show that you guys might be recognizing called The Good Place, which actually has a couple of DI episodes, our outline today, our agenda will be an overview of how all these pieces fit together. We'll do a deeper dive into AI and machine learning just to make sure you guys have a level set. I hope in 5 minutes to give you, you know, really 50 to 60% of what you need to know in order to manage AI machine learning initiative in your space. And I know that sounds ambitious, but we're really got a lot of stuff that we can cut through to make it clear what the role of this technology is. We'll give an introduction to DI, and then we'll take a deeper dive into how all of these pieces fit together for purposes of COVID. So in order to introduce this, I'd like you to consider this little video. I had COVID a couple of weeks ago, and while I was sick, I had, I don't know, I guess a bit of an epiphany that DI and COVID were really good fits for each other, that we really needed decision intelligence for COVID. So I went back to my roots and I started coding. I put together this little demo that illustrates my vision as to how things work. What you'll see on the left-hand side is, in this case, one decision. Now, ultimately, we have dozens and dozens of decisions whose results interact in non-obvious ways. And so I'm really giving a simplified view of things just so you guys can understand it better. What you might have seen is a slider here moving back and forth to increase our investment in a social distance campaign. As that slider moved, these little simulated people moved further apart from each other. On the right-hand side, we have outcomes. So again, decisions that result in actions that we might take. Outcomes on the right-hand side are the results of those decisions as they play out over time. Again, this is an oversimplified model. Right now, my only outcomes have to do with sickness levels. The real power of this technology is when we're trying to balance multiple outcomes. We want to keep our businesses viable because they have important social benefits. How do we balance the decisions we make about taking people back to work against their health and wellness? Well, I believe that data has one role in doing that. Predictive models have another role. We see those in many places around the world and around the country. But all of those stop short of helping us make decisions, helping us see in a visual and visceral way the impact of our decisions on their outcomes. In this case, we have people walking around an outside space, and we've got various decisions about how we might invest in campaigns to keep them safer. So we have decisions, we have outcomes. The third element here are externals. These are things that we can't control. These are what most of the models today are giving us information about. The number of asymptomatic cases per 1,000 people probably spread out over the next 6 weeks, so this is probably a curve. The number of immune people per 1,000, if there are any at all. I mean, the jury's still out on whether I'm immune because I had COVID a couple of weeks ago. Average citizen compliance with social distancing metrics. So again, core to decision intelligence, and if you remember nothing else, it should be this simple picture, is that we have decisions, we might also call these actions, we have outcomes, which is a fancy word for just results, right? And then we have external factors. And keeping those three things distinct is one of the core principles of decision intelligence. So as I was listening to the news last night, I've been modeling interior and exterior spaces separately, but I think there's starting to be an increasing recognition that we really need to understand that anybody in an internal office space is entering that office from an external space. And so there are deep interdependencies between what happens internally and how people get sick and externally. I think most people on this call are probably focused on internal spaces, but much of what I'm talking about is relevant to both of these. So we do have general purpose meatpacking plant models and nursing home models out there, but as we move forward, the technology is allowing us to go beyond general purpose models to understand what are the effective interventions in our space, in our town this month, in the impact on our outcomes, and then also how that interacts with people's experience as they walk around outside. So what we're talking about today is, again, decisions we might make, outcomes those are going to achieve in both internal and external spaces, and how those are going to impact COVID health. So that's kind of the view. If you think of decision intelligence as a car, this is sort of the driver's seat. Anybody can understand a model where we see people walking around. There's these little red particles they're giving off. They're catching COVID. Because many of our audience members today are technologists, I'll be going back and forth between technology concepts and also policy and decision-making concepts. So we're really straddling that line between folks who are looking to make policies based on smart evidence, based on the most data they have, really trying to get at the policies that achieve the greatest value possible, and the technologists who are working to support those folks with data and with AI and ultimately with DI. So again, for those technologists, and this is also for the decision makers, this is what's called a causal decision diagram. More simply, it's just a decision map. This is one of the key pieces that's been missing from complex decision making over the last 20 or 30 years. It is really the blueprint that allows and if you're trying to build a building without a blueprint, then the HVAC person and the electrical person, all those guys, they don't have a single picture that they can align around. Well, this is a picture that technologists and data people can align around. So it's pretty simple. It looks complex, but there's outcomes. Maybe our goal that we're going to focus on is to keep down the new hospitalizations amongst our employees, but we also might care about business margins. On the left-hand side, again, are the actions that we might take. So here it's the amount we might invest in social distancing initiatives over the next 6 weeks. Again, this is very simple, only for purposes of keeping it simple at the beginning. Going forward, and in a real decision model, you'd have typically dozens of decisions, and you'd be mapping how you think those interact. And we'll go into more detail on this later. I just want to give you a high-level view to start with. We'll go into some details about machine learning and DI, and then we'll return to this picture. Machine learning and other technologies fit into the links along this path from actions to outcomes. So we might have a machine learning or, arguably a clinical trial result that says, okay, for every new COVID case amongst our employees, here's how we think hospitalizations will change. For every dollar we spend on a social distancing initiative, here's how that actually affects social distancing amongst our employees. Each one of these links can be informed by a variety of technologies. I think one of the key points I'd like you guys to sit with is that often we don't have data or clinical trials to inform all of the decisions we might make and all of the outcomes that we might be interested in. Most people's response to that is just to throw up their hands and say, okay, let's just do what the government tells us. And it turns out with the combination of these technologies, we don't have to throw up our hands. We can actually dig into this and get good evidence-based decisions, even if we're missing data for some of the links. I mentioned earlier that this technology and this approach goes beyond COVID. I've been evangelizing decision intelligence for 10 years, doing everything from government budgeting to corporate decision-making about new products, to helping governments with health initiatives. And so what we've realized is that there's a class of problems that everybody's just beating their heads against the wall on these problems. They're very unsolved. Some people call them the wicked problems. They're invisible, have actions at a distance, they're exponential, interdependent. Climate change is a problem in this space. Certain kinds of conflict situations, distribution of water and food. So COVID, in a way, has a small silver lining in that I don't think everybody kind of went home and talked about exponential curves 6 months ago. Now we're all getting a level of evidence-based decision literacy that we didn't have before. And so I just wanted to make a little nod to lots of crises, whether you're a government trying to manage those crises in the next 10, 15, 100 years, these techniques are very relevant for. Also, if you're an individual. So that's a lot of complexity, but the question we're trying to answer is actually very simple. And it's this: all of decision intelligence really focuses on this question, whether it's me talking about DI or Cassie Kozyrkov at Google or the folks at IBM. Anybody who's doing DI is really asking this question: what is the result or the outcome if I make this particular decision, which results in this particular outcome, which results in this particular action? And this cloud between decisions and outcomes, whether I'm trying to decide which college to go to, will it make me happy, which product I should launch, what will it do for my company, which climate initiative, which COVID social distancing initiative. What we're trying to do in DI is clear up this cloud, is to give us a better connection between the decision we make and the outcomes we're trying to achieve. Now, let me take a moment and really emphasize better connection. Lots of folks who come from academics say, well, we don't have any data here, and when we do have data, our models aren't very good, therefore we shouldn't engage in this problem at all. That's a big mistake, because people are making decisions today using really no evidence at all, right? They're getting in a room and they're talking and they're doing their very best. Just because you don't have data, just because your models aren't perfect, doesn't mean you don't have a role in making things better, right? 2% improvement in how people make decisions in this space can save a lot of lives, right? So don't let the perfect be the enemy of the better than people are doing it today. And I'll have more to say about that a little bit later. So again, back to our oversimplified decision. Again, ultimately we'll have dozens of these. The question we might be asking is, how much should we invest over the next 6 weeks in a social distancing marketing campaign? And what kind of a social distancing campaign might we use? Put up signs, run seminars, have supervision, we might do some combination. And then the other decision we might have available to us is, how many of our employees are we going to ask to be physically at our facilities, and so they are at risk for additional COVID danger by asking them to come to our facilities. Again, this is happening in the context of external factors that we can't control. We have certain demographics of our employees, which makes them more or less likely to follow social distancing policies. We have a set of predicted COVID cases in our geography over the next 6 weeks. A key aspect of this kind of work is these predictions are going to change, and so we will be incorporating those changed information over time. We might also have a predicted level of government messaging, so the government might help us to ensure compliance and social distancing over the next 6 weeks. So once we've got our outcomes, in this case, again, simplistically, ultimately we probably have 5 or 6 outcomes we're trying to achieve. And once we've got our decisions and externals, we start to say, okay, what's the path from decisions to outcomes? Well, all of these initiatives are supposed to decrease the social distance among our employees, and that's going to be affected by the amount of messaging that comes out of the government over the next 6 weeks as well. That social distance is also going to be affected by the number of employees we have, obviously, so there's another connection there. And then that's going to influence the number of COVID cases amongst our employees, right? How far people stay apart from each other, how many people we have in the office, how many COVID cases there'll be in our geography, how much government messaging there is. You know, all of these factors combine to give us a prediction for the new COVID cases that might not otherwise happen amongst our employees, and then that would lead ultimately to hospitalizations. So, you know, kind of a simple decision model with this one hospitalization outcome. As a business, we are also in a really tough situation. We're beholden to our shareholders also to maintain margins. And how can we possibly make this trade-off between, you know, human lives and sickness and the margins that we achieve as a company? One path to helping us make that trade-off and doing it ethically is to be extremely transparent to our employees, to our unions, to everyone we might be working with about what we think are the implications of the choices that we're making. So we are asking more people to come into work because we think it will improve productivity, it'll raise revenues, but at the same time, this social distancing initiative will have a cost, and those are 2 inputs to our margins. Of course, there are many other inputs. Now, the good news I have to share with you guys is we have seen in many other initiatives in which there's some social good outcome as well as some, you know, cold, hard business outcome. There are often feedback effects. As you start to be a good company and people find out about that, they are willing to spend more with you. They are willing to, you get a competitive advantage. And so for the right kind of strategy, this does not have to be an either or. It does not have to be a zero-sum game. However, we will only understand that strategy if we understand those kinds of feedback effects. So for instance, if we have new hospitalizations amongst our employees and we keep that pretty low and we work really hard with a transparency campaign, that might have a positive brand impact compared to other folks in our space. And take a look at this feedback effect. We might be able to charge more for our products, which means we have higher margins, which we can reinvest into all kinds of initiatives that keep our employees safe, which then, again, this is simplified, would in this case increase the social distance, reduce the number of COVID cases, reduce our hospitalizations. At the same time, we're improving our productivity. So the idea here is to set up a feedback loop where we are profitable enough that we can really maximize the degree to which we can keep our employees safe through a variety of initiatives, and not to treat this as a zero-sum game, but to understand this is a feedback effect, it's complex, it's exponential, and without this kind of a map, we won't be able really to understand. I mean, I know this is spaghetti, right? But imagine trying to keep all the spaghetti in your head. This is what most organizations are doing, is they're keeping these cause and effect links in their heads without a blueprint, and their heads are exploding, right? It's really hard to be creative and constructive and collaborative when 90% of your brain is used up, keeping something like this in your head. And now imagine we have 20 decisions we're making and 12 outcomes we're trying to balance between. We need computer help to do this, but we don't need computers to get started. And so let me switch to a take home here. Business leaders, don't wait for technology. Please, right now, do the following steps on paper or on a whiteboard to set your projects up for success. Spend some time first understanding how you're making COVID decisions today. Keep in mind throughout this process, our goal is not perfection. Our goal is to improve compared to the baseline. Now, marketing people who are probably some of the biggest users of artificial intelligence, they get this. They get that their models are not going to be perfect in their ability to send like the right ad to the right person. All they're looking at is a concept called list, right? How much better can we do? And even if we can only do 2 or 3% better, there's huge value. So you don't need perfection. Your data doesn't need to be perfect. Your models don't need to be perfect. All you need to do is have some belief with a little bit of extra evidence or structured decision-making power that you can do better. Align around your outcomes. I do a lot of decision intelligence consulting. Almost every organization that I visit, there are as many views of the goals that people are trying to reach as there are people in the room. And each of those people, especially if they're senior leaders, are making very impactful decisions that impact hundreds and hundreds of decisions per day. So all the tech in the world, if people are not aligned around what they're trying to achieve, they're going to be pulling in opposite directions. So there's some very basic, non-technical human decision structuring stuff that really needs to be a prerequisite. Draw a picture of your outcomes. Read my book about how to do that in the most creative and structured way. What I have almost universally found is when you allow space and brainstorming and creativity to drive your outcomes, you will surface hidden agendas that, if they aren't surfaced, will actually create difficulties in you achieving your goals. Then aligned around outcomes. This is also a pretty exciting place. If you can create a space where we can creatively say, here's all the things we could do to achieve our goals. Again, almost every time we go into brainstorming mode, no ideas are bad. We say stupid ideas and bad ideas for actions, we could take, maybe we should bring an elephant to the office and paint him and that would make everybody happy. You have to say these ridiculous ideas, right, to get people's creative juices flowing. And again, you can read about that in my book. Almost every time people think of actions they could take that they hadn't thought of before. That's really exciting. Map those. Identify data sources. Notice data is not at the top of this list. Don't let data be the prerequisite. Even as a simple map on a whiteboard where you align around the structure of your decision without any data and any tech has a huge amount of value. One of our early customers was a bank that did this. They laminated the picture, distributed it around the company, and they said that was worth millions of dollars per year just to have a picture of how things fit together in this very complex, previously siloed environment. Don't just stick to data, guys. There's human experts out there. Again, you won't have data for every part of your decision, and so it's very important not to overlook human expertise. Then you can start doing that mapping. And by mapping, I don't mean anything fancy, just draw the boxes and the arrows. And those of you from tech, we're not drawing an ER diagram or a data flow diagram or a sequence diagram. We're drawing a causal decision diagram. And so it's got boxes and arrows. It looks like things you might have seen. It's not a Gantt chart, right? It is a decision diagram which captures causal influence. If we take this action, here's what we expect the outcome will be. And so it is a little bit different than those other diagrams. And so, use the examples in this presentation to get you going, and then you can also read about this to get more information. Look for feedback loops. Feedback loops in these spaces are the invisible engines that lead to winner-take-all dynamics, that lead to these magic holy grails where you can get, your cake and eat it too, where you can get these feedback effects as people have discovered in climate and greenhouse gas emissions. You do the right thing with carbon tax and your business can be more successful because it's taking social value and externalities into account. The larger our businesses are, the more this is true, the more our success depends on the success of the economies in which we sit, the social environment, and the health environment in which we sit. So ignoring externalities and feedback loops that involve humans and mental health, as some DI folks in Japan are starting to look into with DI, that ignore these intangible effects, really is shooting yourself in the foot. We need to really embrace the full complexity. And guess what? We can do it by just starting to draw these pictures. Imagine we were doing project planning without Gantt charts. It would be really hard. Or, software design without some diagrams of where the objects fit together. You can tell my software biases. We need these pictures, and without them, our heads are going to explode. Technologists, bring relevant data sets to the table and use the decision map to focus your data collection, cleansing, and governance. Don't cleanse all of the data in advance. Data management, as you guys know, is a giant, hairy mess. And what's great about the decision model is it can focus you on the data that has the most value in driving the decision. That context can be very focusing. And so you need to work, don't just throw your cleansed data over the wall or create a master data model or, spend a year and a half making a big joined up database or a schema. Work interactively and iteratively with your decision makers because they will give you guidance as to the data upon which the decision is the most relevant. And most people don't do that. We have a culture of the data guys being really separate than the decision makers, and that creates tremendous inefficiencies because, if we know that our decision model is really dependent on, a particular kind of data from our organization, let's say we discovered that, certain demographic groups, are more influenced by one kind of social distancing campaign than another, and that's going to have the hugest impact on our coronavirus illnesses in our organization. Well, that's where we need to maybe forget about cleansing the old data. Let's gather some new data because it turns out that's where the greatest value is. So we're really turning data on its head and thinking about it in quite a fundamentally different way. Okay, so we're going to take a little dive into AI and DI, and in the next 15 minutes, so this is going to be pretty fast, we'll pull all of these pieces together. So I know a lot of you know AI. I'm going to just talk about this at a high level. If AI is a Ferrari car, I'm not going to open up the hood. I'm going to talk about how you drive it and how it gets you to the grocery store. I'm not going to spend much time on this slide. AI is, lots of things. The problem with AI is it's so sexy from a Hollywood point of view, that HAL is opening the pod bay doors and the Terminator and, all kinds of stuff. And I'm really focusing on practical AI. I'm not worried about long-term AI apocalypses. I'm using primarily in my practice supervised deep learning in various forms for many decades. A while ago, it wasn't so deep. It was just supervised learning. And but I think it's important to point out that although I'm focusing on supervised deep learning, AI is definitely a little bit bigger than that. But I think supervised deep learning is the thing you should learn first because it has the most value. So what is machine learning really? Machine learning at its core is a way to program computers. But instead of writing code, we are showing the computer, usually it's just a single flat file, a text file, that says, for this input, here's the true output. For this input, here's the true output. So for instance, let's pick a COVID example. Here's all this clinical data. Here's my O2 levels. Here's, various, clinical blood work information about me. Here's how often I cough. Here's my various symptoms. Here's my age and my gender. And then that's all like these columns in this big table. And the row is me, and the next row is somebody else. I mean, this is really simple, guys. And then this right-hand column is special. It says whether I tested positive or negative for COVID. So imagine we had a training data set like this. And we fed it to machine learning. It can automatically write a little computer program that'll tell, what it thinks its likelihood that I have COVID. 2 reasons this is great. 1, it's easier, faster, because all we have to do is collect examples. And in some situations, those examples are free. Like in an advertising thing, we can check, when somebody clicks on something, so we can get feedback as to whether an ad was good. In some situations, it also produces better code. Image recognition, has been around as a discipline for many years, but these days we don't really do much coding. Well, we do some, but the core, the brain in the middle of image recognition systems, is a system that just learned from examples. That we didn't write code for it. And so here's what it looks. Once you have built a machine learning method, we'll talk about how they get built, you have this thing called a model. It's just a piece of code that gets automatically written. The model, in this example we're doing, takes clinical information about a new patient, somebody who it didn't learn from, and it tells you your likelihood to have a disease. And, this could be all kinds of things. It could be, here's a picture, tell us where the faces are in this picture. Here's, where somebody clicked around a website. Here's the likelihood if we show them this ad that they'll click on that ad after they've looked around a website in a particular way. Lots and lots of examples here. But what's common is, we have some set of information and we feed it through this thing and it tells us usually some kind of a score or a classification. Supervised deep learning is just all the stuff that makes that model automatically, and it usually happens on big computers in cornfields, in containers, or maybe on container ships offline. I love the idea that I'm pushing a button and suddenly there's some computer somewhere in the world that's spinning up, and my robot is learning on my data. It's a great field to be in. I invite you guys to it. Very powerful. So again, what machine learning does is it just takes this training data, and the right-hand column is this ground truth. Did the person click? Were they sick? All sorts of stuff. Feeds it to the machine learning box. Notice I'm not opening up the hood, because what's most important is not how this works inside. Lots of people can drive cars without ever opening up the hood, but how it happens outside, that it takes a set of training data, churns through this thing in batch, and then produces this model. So guys, this is the most important thing you need to know about machine learning. If you don't, how good is your training data? How good is your machine learning? How good is the model that it produces? How do you measure how good that is? This is the template, and everything else, at least in supervised deep learning, which is where, in my uneducated opinion, is about 85% of the machine learning value in the world right now is from these methods. Machine learning, in addition to producing the model, tells you a couple things: which attributes are the most important in making the decision. So it has this ability of explaining itself a little. It turned out somebody's hair color didn't matter, in predicting whether they had COVID or not. But it turns out the result of this blood test, was highly predictive. But of course, we also had to take their weight and other factors into account. And it also says how accurate is the model. To date, we tend to do, overall how accurate is the model, but you should demand of your machine learning people, how accurate is it for specific subgroups? Like, how accurate is it for African American men, for older women, for groups that might not be well represented in a population? It's really important. This is, the essence of bias in a data set is, does it do a good job on groups that might have been historically underrepresented when we train things? I'm going to skip this slide. You guys can take a screenshot and look at it. Most of what's going on in COVID right now that you'll hear about is something called a randomized control trial. It's a prospective study, meaning you design an experiment and then generate the data. Machine learning is typically retrospective. We have an existing set of data and we use it to analyze things. So I just wanted to raise this distinction because in a COVID situation, we have access to both of these kinds of analysis tools that will help us. And I notice we're getting a little close to the end of the time. So let me just give you some take-home actions, and then we'll flip to the end of the deck. So business leaders, buy, don't build as much as possible. You know, if you're a large company, you're going to have an in-house analytics group. Don't, you know, use existing models as much as possible to support your decision making. If it's hard to find AI people, the courses out there like Udacity and others are so great that smart software engineers can learn machine learning. Focus them though on those outside of the box considerations. That's a little bit harder because a lot of the machine learning courses are going to teach you under the hood. They're going to teach you, you know, microwave engineering, but you want to be chefs. They're going to teach you automotive engineering, but you want to be drivers, right? So there's this huge distinction between using the thing and building the thing. So try to get them trained how to use the thing side of stuff. Ask them to explain the input and output, not the inside. Don't start machine learning too soon. Start with the decision context because that will give you a massive focusing influence on your data and machine learning techniques. Technologists, I invite you to join the exciting and thrilling world of machine learning. There's massive value here, not just for the use cases you might already know about, but a lot of the most important problems of humanity, right, like COVID, as we've discussed today, as well as you know, climate and others, need machine learning to help define patterns. And then go beyond machine learning. Learn where machine learning methods can inform the action to outcome path. And this big mistake, again, defer substantial data cleansing or governance until you understand what's going on. So I'm going to switch, I'm going to wrap up in the next couple minutes. I'm going to go a little bit fast. Really what I wanted to show you here is I want to return to this picture, and I want to show you where machine learning fits in. So we talked about how we might have a machine learning model that some other company built that we might adapt for our own purposes that says, okay, for every dollar you invest in a social distancing initiative, given, you know, things about your population, here's how much social distance that you can expect. And then there's probably another study out there that says, okay, given how much social distance you have, here's how COVID's going to respond to that. So models, machine learning models are candidates at many places here. But then it's also important to realize that human experts, when you don't have data, also have a role to play. And sometimes it's just math. You know, margins are a function of revenues and costs. You know, math can be used to say, okay, we've got this much extra money. You know, how much of that are we going to invest in social distancing campaign? So these models are kind of a mixture of all kinds of techniques. Don't just focus on one kind of model in general. So with that, I think I will flip to the end. I will invite you guys to learn more about decision intelligence. Gartner sees DI, this was from 2019, last year, as an emerging important technology. I think it's so important we need to accelerate it to get it into the mass market because it solves the kinds of problems we're talking about here. Lots of companies are starting to emerge that think about decision intelligence in this way. You could read about a lot of them in my book. And let's see, I think I am done. Let me go to the thank you, and then I am delighted to take questions going forward. Thank you guys very much.
Thank you, Dr. Pratt. That was a fantastic presentation, extremely interesting. We have several questions in the question and answer box. I welcome all the attendees to continue to go ahead and post some questions there. We'll take some time to answer as many as possible. One thing I will call this time, this session is being recorded, so we'll be sending it out to the email that you registered with. So I just want to make sure that everyone's aware of that. That's our most popular question, by the way. All right, first question for you, Dr. Pratt. Is RPA and AI the same or different?
No, RPA stands for Robotic Process Automation. And, you know, it's one of those AI terms that different people define in different ways. The most widespread definition of RPA is when you use AI to surf websites, right? So in the past, we might have scraped websites. So, you know, you might have a tool that, you know, drills down to try to get some data off of a website, following their terms of service, of course. RPA usually refers to tools that go out to other websites and gather information and operate either internal or external sites using an AI system. So RPA is one application of AI, but AI is much broader than RPA. Great question, thank you.
All right, see the next one. It seems to me that with COVID-19 use cases, there's not enough data to apply machine learning. While DI can certainly benefit from machine learning / AI, there are a number of DI use cases where AI may not have as much relevance. Can you speak to that?
Yeah, absolutely. I agree. I think the jury is still out on what are the most important places where machine learning fits into the loop like this. So two things to say. One, you're right, we might not have retrospective data for many of these links. But just because we don't have retrospective data for the whole picture doesn't mean we might not have some study where somebody's looked at social distancing in a non-COVID context. And so from a piecewise point of view, we can bring AI to bear. So that's kind of point number one. Point number two is a lot of people think you can't start an AI project until you have data. And I'll tell you one of the kind of senior AI practitioners' secret weapons is many people build AI systems such that they gather data along the way, right? And so at the beginning, you might use, you know, just human expertise to draw a curve to inform one of these links, but you can build AI systems that gather data as you go. That, you know, if people opt in and are willing, you know, with the privacy, you can track people as they move through your space. You can understand, you know, here's some people, you know, that we give one side of social distancing campaign to, and then, you know, another set of people had another social distancing campaign, and so that collects data over time, and then you can keep retraining your models and improve over time. It is a common misunderstanding. You know that CAPTCHA thing where you have to like click on the pictures that have the cars in them? That's actually gathering training data for machine vision applications. So be clever about how you collect data and then learn from it. And again, you don't need any technology to draw a picture like this. And a picture like this has huge value, and it will give you guidance as to where you want to be collecting data when you don't have it, because your model is sensitive to that. Great question.
Thank you, Dr. Pratt. Let's see what the next one is. If a business is going to choose to have workers on site, even though it's geographically impacted, does the approach then turn to harm reduction?
If a business is going to choose to have workers on site, does the approach turn to harm reduction?
I think the point was there that it's geographically impacted by the event.
Right. So yeah, I mean, I think that's a really good way to talk about it. Is if a business has made this decision, and you know, you don't, let's say you as an individual working at that business, or you as a manager, you know, within that constraints, you're given no choice. There's people, you know, working in your facility. Now you do, you know, need to focus on harm reduction techniques. I do think that's absolutely the right way to think about it. I also want to add to that, which is I think transparency is really important here. So there's a lot of jobs out there that are risky. Formula One race car driving is risky. Coal mining is risky. We do have people who take on these jobs, and we don't question their ethics because we're transparent about how risky things are. And so I think our approach is both harm reduction, you're absolutely correct, but it is also transparency. It's transparency into the rationale and the expectation of sickness. I think we owe it to our employees to be as clear as possible, and that's why these kind of visualizations, I think, really help. Transparency is not achieved by throwing somebody a research study that they can't understand, nor is it achieved by sending them a lot of charts and graphs that, you know, they look at and they say, so what? I don't understand. My real question is, if I take this action, if I choose to work with you guys, you know, what are my chances of getting sick? You know, what will the outcome be? And it's our obligation to explain that as best we possibly can. And so it's both. It's harm reduction and transparency, and then to allow our people to make decisions as much as we can.
All right, thank you. Next question, and I got this one twice. What tools did you use to create your simulations?
So we have some in-house tools that we use. So we have a product line called World Modeler here at my company called Quantelia, and it does kind of back-end cloud simulation as well as has a number of front ends. So you guys can, you know, there's lots of tools that are out there that you might choose to use. I chose to use our internal stuff because we've been developing it for 10 years, and it allowed me, you know, in just a matter of weeks to build this simulation because we have a pre-existing framework.
Great, thank you for that. Let's see, next question. How does DI differentiate from AI, and how does DI and AI work together using technology tools?
So Jim, did you say BI as in business intelligence or DI as in decision intelligence?
DI as in decision. Sorry about that.
Okay, all right, great question. I think this slide kind of answers that question as much as I can. So let's say, you know, you're thinking of an investment in a social distancing campaign with a particular staff demographic makeup, and you're trying to figure out, you know, what's the expected average social distance. This is the model that we've been using as an example, although as we talked about, it's one of dozens and dozens of models that are possible. So AI will give you this model, and, you know, it'll also tell you how accurate that is. Okay, so we have this expected average social distance. DI helps you to understand, okay, now what? You know, so I have this model, you know, what do I want to do with that, right? And so DI says, okay, given that we have this AI model, here's the decisions we might make, and then here's the outcomes of those decisions. So DI puts this sort of context around the model, and it uses the model as part of this mapping from decisions ultimately all the way to outcomes. And this is true, you know, in COVID, but lots of domains. Like I did a security project that said, what's the likelihood that we're facing, you know, a cyber attack right now? Okay, it's 92%. So what? Okay, right? So we're getting a cyber attack. Well, there's now like 6 choices we might make. We could call the police, or we might do an internal investigation, blah, blah, blah. It's really answering the so what question, right? It takes you from a prediction to a decision.
Great, thank you. Let's see this one. Okay, in the case of COVID-19, we're using unsupervised learning. How can we implement neural networks for predictions?
So for those of you who don't know it, unsupervised learning is where you don't have that right-hand field in the training data. So all you have is, you know, here's this training data set. All you have is, you know, in this example, it would just be clinical data. You know, I'm the first row, my clinical data, my demographic information. The next row is somebody else's clinical data, their demographic, blah, 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 blah. In unsupervised learning, we don't know whether they ultimately got COVID. And we can still feed that to a machine learning engine. And what it does in that case is it can just say, is this person particularly unusual, right? Compared to what was in the training data, is this person an anomaly? And so it's called anomaly detection. The problem with unsupervised learning is if we've got fields in there like my hair color, it doesn't know whether hair color is predictive or blood, you know, results are predictive. So it might label me as anomalous and unusual compared to everybody else because my hair is pink, right? But that's not predictive. So we'll get a lot of false positives. We'll get a lot of, the model will say this person's unusual, and yeah, I'm unusual, but not in ways that really matter. So I think optimally, if you're doing unsupervised learning, you use that upstream of some human intervention. So it might say, you know, this person's really unusual, or the situation's really unusual. Again, I don't know what you're doing with your unsupervised learning, and then it can feed that to a downstream person, a human, who says, okay, are they unusual in an important way or in a not important way? The other way we might use unsupervised learning, sometimes people do this in advance of supervised learning, and that's getting into some technical stuff that has to do with transfer learning, which I invented many years ago. So contact me offline if that's your use case for unsupervised learning.
Great, thank you, Dr. Pratt. Let's see, I like this one. Machine learning and AI are growing technologies. Are there any technologies coming that are better?
Decision intelligence. Again, we still need AI. DI is not a substitute for it, but it's really fundamentally limited because it doesn't answer the most important question. So what, right? And so I believe that we will be fundamentally limited if we stick to AI and we don't put it into a decision intelligence context. So this is my opinion after having, you know, spent blood, sweat, and tears on this for 10 years, after having done some pretty major market research. If you're not convinced, take a look at my book, and hopefully it will convince you. I used to be kind of humble because I invented this, and I go, oh, it's just my silly idea. In recent years, I have seen so much success out of DI and so many organizations starting to take it up that I'm completely convinced that this is the most important new technology, if not for the century, then at least for the next couple of decades.
Thank you, Dr. Pratt. Looks like we have time for one more question, and I want to thank the audience for all the great questions you guys have provided. These have been really, really good. Let's see, last question then before we shut things down. One of the main issues about COVID right now is how to relate COVID dynamics with economic outcomes like unemployment, poverty level, shrinking economy.
Yes.
What kind of analysis sequence and tools would you suggest to deal with this?
I love that question, and it's great that it's the last one because it's probably the most important we face. Start the way I said, by mapping outcomes, right? So typically, let's imagine we're in the government, right? And we care about economics as well as the health and happiness of our citizens, right? So don't worry about technology. Start by mapping those outcomes. Again, it's like we're doing project planning without even the discipline of drawing Gantt charts, let alone having Microsoft Project, right? So read my book, draw the pictures because it'll teach you how to do that. And if you don't want to read the book, there's a lot about it on my blog at lorienpratt.com. And so the most important quote unquote technology is to draw a blueprint to get everybody on the same page. Number one, what outcomes are we going to try to achieve? Just list them, right? We'll deal with the trade-offs between them later. Simply listing the outcomes and agreeing to them is a really important first step that everybody's skipping. It's kind of crazy because they kind of want to jump to the technology. But, you know, if you don't know where you're going, any road will get you there, right? So start by aligning around outcomes, then align around decisions, and then draw, you know, these kind of spaghetti diagrams where you map how those decisions impact the outcomes. Again, there are a number of teams, and if you contact me offline around the world, who are doing packages of these kinds of decision models for COVID, for various kinds of interventions. Simply drawing these pictures is critical. And then if you want to go beyond that and you want to do AI and DI, there's an emerging ecosystem of DI and AI companies that can help you get that evidence-based decision-making sort of in process and alerting you to when the situation changes that you need to revisit your decision. And so again, check out my blog. Subscribe to my blog. That'll give you early information and some you know, kind of insider stuff about how this field is growing and who you can contact to help you.
Thank you, Dr. Pratt. Yeah, if you don't mind just scrolling down to the finishing slides, we'll get this taken care of and get everyone
Absolutely.
on their way. I hope everyone enjoyed the webinar today. If you'd like to learn more about this topic, Global Knowledge recommends the following courses: AI Overview for the Enterprise, Data Science Overview, Introduction to AI and Machine Learning, and Applied Python for Data Science. Also, be sure to visit the Global Knowledge website to access additional free resources like technical articles, white papers, and other webinars. Thank you again, everyone. Thank you, Dr. Pratt. Everyone stay safe, and please have a great rest of your day.
And feel free to contact me offline if you'd like more information.
Thank you again, Dr. Pratt. Bye, everybody.
Thank you, everyone. Be well.